For a long time, this was the sound of high performance. The computer industry had a golden rule: if you want speed, you need power. And if you have power, you have heat. In the early 2000s, Intel predicted that by now, our computers would be running at 10 gigahertz. They thought the curve would go up forever. They were wrong. They hit a physics barrier known as the thermal wall. They couldn't push the electrons any faster without melting the silicon. By 2018, the most powerful laptops in the world were broken. They had incredible processors, but they couldn't run for more than a minute before slowing down. Silicon Valley was stuck in a heat trap. But inside this building, a secret team had spent 10 years working on an escape plan. This is the story of how a mobile phone processor killed the x86 empire. To understand the divorce, we have to look at the marriage. In 2005, Steve Jobs made a desperate move. Apple was trapped. Their old Power PC chips were too hot and too slow. So they went to the king. Intel was the undisputed master of silicon. They had the fastest chips, the best factories, and the deepest pockets. It worked. With Intel inside, Apple created the MacBook Air and dominated the market. It seemed like the perfect partnership. But around 2015, the relationship started to rot. Intel got comfortable. Their improvement slowed down. To understand why this happened, you have to look at Intel's roadmap. They were stuck on a manufacturing process called 14 nanometers. In the chip world, smaller is better. Intel was supposed to shrink their chips to 10 nanometers in 2016, but they failed. Then they failed in 2017 and 2018. For 5 years, Intel kept selling Apple the exact same technology, just rebranded with a plus sign. Such as Skylake, KB Lake, Coffee Lake. It was the same technology, just squeezed harder to run faster. Apple's engineers were hitting the wall. They couldn't make the MacBook thinner because the Intel chips required massive copper heat pipes just to keep from melting. Apple was furious. They were trying to build Ferraris, but they were forced to put tractor engines inside them. But Apple had a backup plan. A tiny side project that ran on a battery, not a power outlet. The iPhone chip. Year by year, the phone chip got stronger, until one day Apple realized something terrifying. Their phone chip was catching up to the desktop. To understand how a phone chip killed a desktop giant, you have to look at the language they speak. Intel uses an architecture called CISC, Complex Instruction Set. Think of it as a dictionary filled with 10,000 obscure, complicated words. It is powerful, but looking up those definitions takes massive energy. Apple's silicon uses RISC, Reduced Instruction Set, a dictionary with just 100 essential words. Intel believes complexity makes you smarter. Apple proved that simplicity makes you faster. Intel is haunted by its past. They have to support software written 40 years ago. They carry the baggage of the 1980s. Apple doesn't care about the past. They strip the architecture down to the bone. But this raw speed created a massive problem. If Apple changed the language of the chip, all the old software, Photoshop, Microsoft Office, Steam, would stop working. This is usually when new architectures die. Microsoft tried this with the Surface RT years ago, and it failed miserably because it couldn't run old apps. But Apple pulled off a magic trick. They built a transparent translator called Rosetta Key. It translates the old Intel instructions into Apple instructions in real time. And the craziest part, the M1 chip was so fast, it could translate the code and still run the app faster than a native Intel computer. In a traditional PC, your processor and your memory live in different neighborhoods. To get data, they have to send signals across inches of copper wire. To you, it's a nanosecond. To a computer processor moving at light speed, that commute feels like hours. This is latency. Apple didn't fix the road. They eliminated the commute. They built a system on a chip. The memory and the processor live in the same house. They don't need to copy data back and forth anymore. Intel components talk to each other. Apple components are telepathic. And then there was the battery. For decades, high performance meant being tethered to a wall outlet. If you unplugged a traditional gaming laptop, The performance would drop by 50% instantly to save power, but the M1 changed the physics of mobile work. Suddenly, video editors could render 4K footage in a coffee shop on battery for 6 hours straight. The charger became optional. This fundamentally changed how professionals used the machines. When Apple revealed this chart, the industry didn't believe it. It looked physically impossible. Intel laughed. They ran ad campaigns mocking Apple. They claimed that real computers still needed heat and noise to be powerful. But then, the reviews came out, and the laughter stopped. A fanless entry-level laptop was beating Intel's most expensive workstation. The hierarchy of power had been inverted overnight. Today, the denial is over. The entire industry, Microsoft, Qualcomm, even AMD, is racing to copy Apple's homework. The old x86 architecture is walking dead. We have entered the era of efficiency, where the winner isn't the chip that burns the most power, but the one that wastes the least. And if the old guard can't learn to speak this new language, they won't just be slower, they will be obsolete.